Hi, welcome, and thanks for joining us again for another episode of our TACT Talk. Today, I'm going to discuss welding, something that happens in every process. Every piece of equipment in your facility has welds in it. We're going to talk about sanitary welding particularly. So a typical sanitary weld is a TIG weld, or tungsten inert gas weld. It's done thousands of times in every process, every piece of equipment. A lot of times people don't appreciate that something like this actually is welded. This is actually five individual pieces that have been welded together. There's a weld here and here and here, and even this is a full weld. Now this weld has been removed, meaning that it's been ground, it's been polished, and blended to look as if there was never a weld there, and it's quite frankly a very good job. There's nothing wrong with removing welds. However, there's a good reason sometimes to leave welds, and oftentimes in many applications we do so. Here's another example of a part that has many welds in it. There's welds here, there's welds on this, there's welds in this area. Again, done very well. But this is an example of a part, and as you can see, welds have been left. Now they've been color cleaned, and you might ask, what does that mean? What does color cleaning mean versus grinding and polishing? Well, color cleaning is a process by which, when you make a weld, there's discoloration. The heat of the metal being melted together causes that metal to discolor. And if we look at that discoloration, it tells us a lot about how the weld was made, if the weld was made properly. Now you can look at the weld itself and tell a lot as well, which is one reason why leaving a weld is a good idea at times, because you can tell the quality of the weld by looking at it. But we also care about the color. Even when the weld looks good, the color in the weld before it's been color cleaned matters. If we look at the American Welding Society D18.2, it's a really good chart. It shows us both what they and EHEG, or the European Hygienic Engineering Design Group, say about weld discoloration. And depending on the industry you're in, whether it be biopharm or food and beverage or semiconductor, the weld allowance, the amount of color left in that weld, is going to vary by each of those industries. Now, why does that matter? Well, weld discoloration tells a lot about what that metal has gone through. Lots of color means it was really hot, and you might have a lot of deterioration in the metal composition. The metal has melted at a very high temperature, and when it comes back together, it's not the same metal. So you might actually have, even though the weld color is removed, you could have potential for corrosion in welds that have had too much heat or too much energy. It also tells us how much oxygen was present. And in any weld, oxygen is our enemy. Oxygen does not make for a good weld. That's why we use inert gas, or in TIG, that's why it's tungsten inert gas. That inert gas, like argon, removes the oxygen. But there's always trace amounts, and depending on how much oxygen is present, tells us just how good the weld was, which also is present in the discoloration. So it's a good idea, if you're having anything done in your facility or if you're manufacturing, to pay attention to that weld color. Again, reference AWS D18.2 gives you a really good idea of what you should be looking for. And don't be afraid to leave the weld. It tells you a lot about how that equipment was manufactured.